Hello, everybody. Thank you for joining us. This is the Space Week New York 2024 Spotlight interview with Rocketstar. They are a New York-based launch and rocketry company. They do a lot of really interesting and fantastic things, and we have a great team from Rocketstar here today to talk to us about all the work that we do. Before we get into that, just some brief introductions. I am Patrick Chase. I am one of the co-founders of Empire Space. We are a New York-based nonprofit that serves as the networking and data hub for the New York space ecosystem. We have a database of the various stakeholders around the state, and we work to network and grow that ecosystem, creating more opportunities, academic opportunities, economic opportunities for the space ecosystem here in New York now and in the future. There's a few other members of our team here. My co-founder, Evan Lerner, is here. Let him give a brief introduction if you'd like.
Sure. Yeah. Thanks, Pat. Yeah, excited to be here for this this interview with Rocketstar. I'm not going to give much of an intro, but Space Week's going great, and this is a great event to end it off. So.
And we also have our new programming manager here, Quadri Bello. He'll be very involved with Space Week 2025. So Quadri is here, and a lot of you folks will probably be hearing from him in the future. But now to kind of turn it over to the suite of guests we have here from Rocketstar. We have Mike Cassandra, co-founder and chief culture officer. We have Wes Failer, CTO. And David Peebler, the chief marketing officer and co-founder. So now I'm going to turn the floor over to them, let them all do an introduction. And then the first question of the day is just kind of who is Rocketstar? How did you get founded? Kind of what was the vision that kind of brought you into existence? So go ahead and introduce yourselves and take us out.
Mike, why don't you go first?
Yeah, no problem. As stated, I serve as the Chief Culture Officer. So under that umbrella, if you will, I have four main departments. I handle our social media. I handle our human resources. I do a lot of our school and community outreach. And once we have enough employees for this to become a real department, I handle employee advocacy. So kind of a lot of hats going on. Based here in the corporate office in New York. That's where I've always been. So I've kind of just held it down up here.
Wes.
Hey everyone, Wes Failer, Chief Nerd Officer, I guess. Chief Nerd. I enjoy that title. I enjoy that a lot, as I've been a systems engineer for my whole life, but software has sort of been the screwdriver. That's the thing. If you know the software, you can go into any factory, you can work on any system these days. So that's been my approach to engineering, is throw some software at it, and that did lead to plasma developments. It did lead to some of the fusion developments. It's certainly led to the DSP developments. It's led to a lot of great places. So big advocate there. But just been a nerd, lifelong nerd with all this stuff. Love particles and basically, if I can bully electrons around in real life or in the computer, let's do it.
Nice.
Love that. My name is David Peebler. I've been a marketer all my life. So it's basically 40 years in marketing and business development. Prior to my working life as a 4-year-old boy, I wanted to be an astronaut growing up in Omaha, Nebraska. But I soon found out that physically that was not going to happen. I wore glasses. I ended up being too tall. So then I wanted to be an astrophysicist, but I don't have the math skills. So I just promised myself that I would be involved in everything astro my whole life and just have it be a hobby. And I was happy with that. Well, in 2014, I met Chris Craddock, who's our founder and CEO. At the same time, Mike was meeting Chris. So Chris had both of us, and Chris graduated college having studied physics, and he realized that many of the technologies that the space program was being built on was decades old. So for instance, the Bell nozzle engine is going on 80 years old. And he really felt that as the commercialization of space was in its nascent kind of beginnings, he saw that that access to space needed to become routine and was going to become routine. So how can a company that he's creating do something, affect that space? And he hit upon the Aerospike engine. So the Aerospike engine has a storied history. It was tested in the 2000s. They didn't have the material engineering advancements necessary to handle the fuel requirements, and they let it go. But now we have that ability. It's there, it's commonplace. And so he saw the efficiencies embedded in the Aerospike engine, which are, the ability for vector thrusting, and the general thrust to weight ratio efficiencies, about 30 to 40% we've experienced so far over Bell nozzle. It's also lends itself well to single stage to orbit, SSTO, and it's reusable just by the nature of the design. So he really hit upon that as a key piece that we could develop out for that access to space. Well, we've had 9 test launches, and what we found, which is no surprise, it's a very costly endeavor. It's costly, it's risky, and while we believe there's a place for the Aerospike, as we've evolved over the last 10 years, Chris had the good fortune of running into a company by the name of MileSpace, the principal of whom is Wes Failer. And Wes had created these amazing products that we will go into later. Wes will talk about them, that Chris saw fitting into this vision. So the Firestar drive, both the foundation drive and the fusion enhanced component of that drive, and our Phoenix Eye digital signal processing suite, currently 5 products, fill gaps, solve problems that are really in demand on a global level. And again, we'll get more into this. So we've evolved with economic necessity and business reasons, and we have found products that are going to fit into the space ecosystem really well. And we're really excited about them. It's groundbreaking stuff. So that's kind of like, where we've come from, how we've evolved, and where our major focus is in terms of our growth. Just as an adjunct to this, currently, Chris Craddock and Brad Berkson, our president and COO, they're in Japan, because on the heels of our fusion announcement, we were flooded by interest from Japan. And when I say interest from Japan, I'm talking a high-level government, I'm talking high-level JAXA, and I'm talking about some high-level industrial interest. So they're over there now for a week having these high-level meetings, and it really has shown us that the market, the interest, and the potential lies at a global scale for these things. So our challenge is going to be ratcheting up, creating the infrastructure, and kind of getting positioned to be able to capitalize on that.
Excellent. That was a heck of an introduction. Sidebar, I can relate to being a guy who is too tall with bad eyesight, who could not become an astronaut, and so turned space into a hobby and then found a way to turn it into a profession. So I am right there with you on that one. So many interesting follow-ups, but I think the fusion conversation will take up kind of the meat of it. So before we get to that one, you've mentioned some of the other products. I know RocketStar has software products and stuff like that. So I guess just tell us about some of the other, stuff that you guys do, some of the products that you've developed over time. You mentioned some of them briefly in that intro.
Sure. Wes, take it from here.
All right. Who's gonna hold my beer? All right.
Gotcha.
There you go. Nice. No, while ago, we had the job of trying to talk to a satellite in deep space. I mean, all these things come from need, right? Chris saw need in the market. Chris and I saw need to benefit to do better in ion engines or fusion. We also saw a need for communication, better, cheaper communication.
Mhm.
I don't know if you've ever tried to buy time on a satellite dish or tried to get somebody to loan you time on their satellite dish. It is not the Amazon point, one click and buy experience. There are companies out there that have gotten really close now, but man, 8, 10 years ago, not at all. Not at all. Not even close.
Hmm.
Still, I don't think it can ever be that close, by the way. But I mean, it's the whole, I mean, industrial purchasing is very different from consumer purchasing to begin with. But with these high value assets, like communication dishes, where you're talking massive zoning costs, operational costs, maintenance issues. Any of those things have enormous. You could look at it as red tape or red velvet rope, so layers of bouncers around them. And so those assets are really out of reach if you're trying to democratize space. And that was a key driver for us as we started to think about how do we get access to communication ability. It's not a dish, but communication ability. And that led us down the software route. Can I solve this with software? Remember, that's the screwdriver I work with.
Yeah.
I've got software tattoos. Software. How can I? That's the hammer I have. Let's go find a nail for it. And it actually works pretty well. I know Dave says get more excited about it. Sorry, engineer, right? And we've got a whole suite of products here, but the real darlings that are getting attention right now, you've got signal boost. So that takes one incoming very weak signal and cleans it up. The remarkable thing is there are a set of equations that are ideal if you know your signal is a little bit stronger than the noise. If you know that for sure, then or if you're not sure the signal level, then these equations work. But if you can be guaranteed that your signal is terrible, you can guarantee that satellite 10 million miles away is putting out a really tiny signal on the little teeny antenna you could actually afford to rent. All right. If you can guarantee that, which is pretty darn easy to guarantee the worst case scenario, it's space. Murphy works in space.
Yeah.
You can always guarantee the worst case scenario. If you can guarantee that, turns out there are other equations that work better in that terrible regime.
Huh.
And that's where we excel. They're not Blackboard friendly. They are not calculus friendly things with smooth differentials and all the things that make really neat test final exam questions. They are not simple things. They're jumpy things. And if you hand them a perfect signal, they will destroy it because they're trying to pull the noise out of it. If you hand them a signal with lots of noise and a little signal, they will tear that noise out, throw it away, and give you a nice clean signal. And that's our signal boost. But it comes from that philosophy of saying, why come up with this universally accepted equation when there is a special case that is the real case that we all work in? And so we have the signal boost product that applies those equations to really terrible signal quality, and it gets rid of the noise and cleans it up. And we're getting a lot of military interest in that product.
Yeah.
Of course, satellite interest, because it now means you could use smaller dishes, etc. You look at say Starlink's made the news with one of their competitors complaining about all the energy coming from the Starlink satellites is interfering with their noise floor. And there's a lot of public debate about whether that's acceptable or not. Whereas our product, if it had been used on the receive side, would lower the energy people need to transmit, so you're less likely to have those kind of interference. So I really see a situation where the FCC is going to start to mandate lower power. And so as soon as products like this really get out there and start to be adopted, there's going to be no reason for people not to employ them, or they're going to want to use them in order to get through the FCC licensing process even easier, because our world ahead is constellations, which, being somebody with an eye in the launch world and satellite maneuvering world, go for constellations. We want as many of those as we can. So you've got signal boost, takes a terrible signal and cleans up the communications for it.
Wes, I'm interrupting you only because I think you're being a little too humble here. Could you tell our audience the fact that what you've accomplished with signal boost is most people believe that it's not possible, and talk a little bit in a couple sentences of what its significance is in terms of how far below the noise floor you can pick the signal up, because that's really the special stuff.
Yeah. So noise floor, that's sort of the background chatter. You're at a coffee shop, there's a background chatter, and somebody's got to be a little louder than that for you to pick it up, right? Unless they're your best friend, you know the slang that you're working with, in which case they're sitting near you, you can see them, you see some mouth movements, and you're catching parts of the words. So their words are below the noise floor, but you have some knowledge about what they're probably talking about. And so you can piece it together from these other situational things. All right. That lets you talk below the noise floor, quieter than the background, if you both have this shared knowledge. Cell phones work that way. There are all these encryption keys, et cetera, that the server towers and your cell phones have, and they share, and that lets you work below the noise floor. So the cell phones can save their battery. They work maybe about 10 decibels below the noise floor. So that's about 10 times quieter than the background chatter. That's pretty common, and just a 3 dB move on that is enough to wipe them out and have them not work. We're able to work at 30 to 40 decibels below the noise floor. So another 100 to 1,000 times quieter than that. So 1,000 to 10,000 times quieter than the background chatter is the kind of conversation we can pick up. So to do the mic drop moment, that would allow you to talk to a satellite 10 million miles away that has less power than your cell phone puts out and really bad directionality, and have it be heard by an antenna the size of a conference room table instead of one of the 3 antennas in the world that can do it otherwise. That's what that enables. That's what those numbers mean. If you took that to a logical conclusion, you could imagine sitting in your backyard with a lawn chair and a Yagi antenna and a beer cooler and talk to somebody on Mars. And I'm sure there's got to be some obstacle to that, but that's mathematically the way those numbers line up. Probably talks, data rate. I don't know if you could probably tell dad jokes because they tend to be really slow, but you probably wouldn't want to do, War and Peace over probably not high enough data rate for good nuance.
Yeah, so I guess just a quick question: what are the limitations? Are there size or other kind of limitations on what you can pick up? What are the constraints there?
There's always a limitation. Physics will bite you somewhere or another. We just found a way to squeeze the balloon differently than most. For us, it's computation, data rates at the front end computing, and the industrial psychology of selling into a base that has picked computing and RF components that go a very different route. And on those components, it's hard to shove our extra computing software onto. And so then that means you've got to sell up into a whole different chain of people. You've got to be at a whole different group than you normally get. So if you talk with operations-minded folks, and their idea is every gizmo coming off the assembly line is perfect because it's can do exactly no more than what was promised, those folks will never embrace this kind of technology. But if you get the few people that are sitting in the ivory tower who make the inventions that make the extra digit in the company's valuation to begin with, then they're going to want to embrace this kind of stuff. So there's a lot of industrial psychology to the sales process and the marketing process to bring out something that fixes a problem that nobody realized they were limited. They didn't know they were limited. They didn't know there's another way to do this. And I could launch into math, and I've had some people challenge me on math for this. And the mandate I get is don't teach them this math that would enable them. This stuff is trade secret. So we don't teach it. So the people that say, hey, this is impossible, like, great, find out who they're selling to, because those people are starving and they don't know it.
Interesting. Well, that sounds pretty quietly revolutionary, especially as we look to move.
I'm really proud of that one. There is clear and obvious math, but you got to be smacked upside the head to look at the world differently.
Yeah, and the math again was not what I went to college for. So in that case, I will never be the one to challenge you on the math. I will defer to you for that. So were there any other in the software world that you wanted to highlight before we start talking about fusion?
Yeah, so there is something that can sense extremely weak signals. It can only sense they're present or not present. So it's essentially the old Morse code, right? You can't use it to communicate data because it's not very fast, but present or not present. So you would embed that type of thing into a radar system. And what's really novel about that is, let's say China were to launch a hypersonic weapon. That's one of these ballistic missiles that goes up, comes right back down, and then skims the surface of the Earth using all that energy. Skims the surface of the Earth so low and so far away, it's never very high near its target. So any radars near the target, like along our west coast, wouldn't pick these things up. So that thing comes skimming in, 20 kilometers up. And by the time our West Coast radars pick it up, it's too late. And if we pick it up with traditional radar, does the thing like you see in Top Gun, where somebody's like, hey, I've got tone lock. You hear the subtle beeps and beep, 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 beep. Somebody's, oh, they've got radar lock. They got tone on me. Well, that's the receiving airplane noticing that it's being painted with energy in a pulsed fashion. Those pulses are getting faster and more continuous. And that's how it knows there's tone lock. Somebody's actually got a lock on it, keeping the radar dish pointed at it. Hypersonic weapon detects that. It twitches a wing and it's 100 miles away. I mean, they're screaming along at 7,000 miles an hour. So you tweak something like that, you alert that you're tracking it, and it just goes away. Yes, it's going to go to plan B as far as where it hits, but it's still devastating. They did not pick low-value targets. They're not targeting empty blockbuster buildings out there as plan B. They are still got high-value targets. So this radar system is sensitive enough that it could use reflected TV signals from, say, a Japanese TV station, just ambient stuff reflected off of a hypersonic weapon, and that those reflections come in at about 60 to 70 decibels below the noise floor. So even weaker than you would do communication, another 1,000 times weaker. And we can pick them up. We can pick them up, clearly pick them out from the background. For us, the background is about 90 decibels below the noise floor for this method. So we can pick them up about 100 million times weaker than the background chatter and detect that. That's got some interest, obviously.
Yeah,
and
I would imagine. One
of the neat things you can do with that is with the right hardware partners, and we've certainly done some good marketing on that. Nice job, Dave. We got some hardware partners that make it possible for us to scan the sky very quickly and apply this kind of technology. And now you can see where's the sun, the moon, the quasars, the planets, etc. NASA, for instance, using planets to help align their dishes. Mm-hmm. It's not an unheard of technique, but we can look for all these radio sources in the sky so that we can see during the daytime, we can see during combat, we can see during anything, and we can tell you where and when you are based on those radio observations. So take that radar and don't use it for radar, but use it to sense where things are hanging out in the sky. And that gives you an alternative PNT, an alternative to GPS that's unjammable. That is getting a lot of attention.
And that works in GPS denied environments. So without any GPS, you can pinpoint anything.
Yep. So GPS denied or GPS spoofed. Yeah. If you look at like a classic GPS antenna, it's just a little round puck. It can't tell where that signal came from. It says, hey, satellite 12 says blah, blah, blah. It can't tell that came from the direction of satellite 12. It can't tell anything. It just knows it got told satellite 12 says this, but it's easy to lie to a traditional GPS thing without any sense of directionality. You can't lie to this device because the planets, the sun, the moon are where they are. Those quasars are where they are.
Ah. Wow.
And probably shouldn't elaborate too much, but if you watch the news in Ukraine and you watch how modern war is being fought with people using modern tools to go slug it out, movement is essential. Location is essential. Nobody gathers their forces on a giant battlefield and then trundles them along at each other anymore. That's bonkers in today's world. So movement's important, which means location services are incredibly important, critical to modern combat, not just say a consumer world and self-driving cars.
Wow.
So that's sort of like the top two pieces of software, with the radar being the enabling one, repurposed for navigation, which was a really novel thing that came out of our marketing efforts. And saw us, I was really proud of our team here at RocketStar. I joined in with RocketStar, brought Miles into the RocketStar family. And that was one of the first things RocketStar did was spot that opportunity to repurpose radar into alternate positioning. And that has opened up proposal opportunities and potential funding opportunities like we've never seen. It's been fantastic.
No, that all sounds. I mean, I came into the interview already worried that we were going to talk for too long because there was already so much interesting stuff, and then you got into this, and I already have like a dozen follow-up questions. But
All right, Dave said be proud, and you asked about my kids. So what are we going to do?
No, we may have to schedule a follow-up at some point in the future just to talk about some of that stuff because it sounds so cool and so applicable. So I guess thank you for diving into that, Wes. But I know that one of the biggest items that you have gotten news for recently, one of the things that has tickled one of my particular nerd fantasies, is the fusion thruster. So I am not an engineer or a physicist by background, so I am not even going to pretend to properly introduce it. I will just mention that it is an evolution on some of the existing foundation thrusters that you have worked on before, and I will turn it back over to you guys to kind of just explain what this is. And people hear fusion and they kind of import everything that they've heard. Right. It's going to be 30 years away forever and everything. So just fill us in, and then we will have follow-ups. Don't worry.
Oh God, do they import everything?
Yes.
It's like all that knowledge comes together and collides, fuses into confusion.
Yes.
So fusion is you take two subatomic particles, usually a nuclei and some other particle, and you shove them together. And when we talk about fusion reactors are really hot, that means that the particles are moving around fast and that they're contained. We often hear news about plasma containment breakthroughs and magnetic containment breakthroughs. That's all about keeping those hot things bouncing between mirrors of a sort, so you get more shots on goal, more chances to hit each other before they cool down. So that's fusion. So you can get them to hit hard enough, they will become bound together, and when they're bound together, you lose a little bit of mass. And go to Einstein's equation, audience homework question, tells you all the energy you get out of that. You'll see clearly how much energy you get out of that. And therein you get some kind of useful effect. But you need things to collide. And the usual way of doing it is some kind of donut or a sphere and hot things that are bouncing back and forth against the walls. And just so you get more shots on goal. So you get to use your things more often. It's a real challenge. It's a real challenge to cause a fusion explosion and contain all that energy or direct it along a particular line. Lots of people work on that. They get metals on the walls, break down. You disrupt the magnetic containment when your plasma suddenly gets hotter because it's got all this fusion energy. How do you extract that energy to do something useful, like power an air conditioner or a computer for a Zoom meeting? What do you do there? There's a lot of challenges when you try to contain that energy. And that was one of the things that came up when Chris and I started working on this. Chris is a huge fan of proton boron fusion because it's attainable. It's very attainable. A little more energy than the hydrogen stuff, but it's easy to get protons. It's easy to get boron. And they're certainly easy to bully around and direct where you need them to go. And so we started looking at it and we said, well, everybody and their brother is looking at the material problems, magnetic problems, containment problems, all containment problems of containing a fusion explosion. And like the old joke says, you know, doctor, it hurts when I do this. And the doctor says, well, don't do that. Well, if it's hard to contain the fusion explosion, what if we didn't contain it? What if you had a thruster and you got all the plume coming out of the thruster? What if instead of putting the explosion inside, put the explosion outside? Would that be of use? And it turns out if you're working with, you know, say chemical type mentality and stuff like that, no. If you've got a big bell jar to try to channel that explosion, no, that's not a lot of use to happen outside. You need that contained inside if you want to do that. But electric thrusters with their glowing static discharge that is their plume, if you pump energy into that with a fusion, it changes the energy efficiency of this guy. And that gives you a side benefit. So it's a 1-2 punch. The explosion is not the benefit. The explosion is the turbo pump that is clearing away the exhaust products. Get that exhaust out of there, and this guy is more efficient inside. What happens inside gets far more effective. In fact, there's a fundamental limit that limits how effective a plasma thruster can be because of all the exhaust out here. So the fusion is used to clear, pumps energy in to the exhaust and clear it out, thereby making this more efficient, which gives us the benefit. So it's not, so we get all kinds of questions. People are like, well, what kind of magnetic fields are you using to contain the explosion? How do you direct the explosion in one direction? I don't have to. Still useful if you don't. It happens out here. It happens all over, and it's still useful. That was the big innovation for us, is realizing there's utility in an unconstrained fusion explosion out here. And further, that the boron fusion is absolutely optimal for inducing that utility, because the boron is so darn slow that you can inject it from all these little dips. These are where the cold boron comes out. You can eject that out, and then the high-speed protons come out. And our particular foundation thruster is amazing on water at producing high-speed protons, just bonkers good at it. So you've flooded that area early up to the opportunity for generating the fusion events. And so we took this thruster, well, not quite this one, because this one's a gutted hollow one, but you get the sense for it. We took this up to a facility in Atlanta, a great test lab, Georgia Tech, high power electric propulsion lab. A lot of PhDs gone through there. It's considered an excellent baseline for vetting your thruster. So superb facility. And we bolted it into, well, we didn't bolt it into anything. They bolted in, because that's the key. I don't know how to bolt this thing into their system in a way that keeps it balanced and perfect and deals with things that literally, 100 man years worth of effort have gone into fine tuning. I'm not going to learn that. So you hand this to them and say, hook it up, and they hook it up. And they deal with all little things, because that's the other thing people do, is they import all their anxieties. They tell them to me. I say, go read 100 people's theses about how these anxieties have been dealt with. Go do that first. So they hook it up, they run it, they deliver the water, they deliver the power, they measure the thrust and tell us how it did. All we deliver are commands to the onboard computer telling it what mode to operate in. So we can say, let's play what if. And their facility, we tested with and without fusion, and relative to the results we got without fusion, with fusion gave us 50% thrust increase and a 50% fuel economy increase, even with the extra boron flowing. it still represented a 50% fuel economy increase without additional power. That's the bonkers thing. And we had radiation sensors on here, and people were like, oh, well, we need to see those values. What's your probability? You know, you buy aspirin, and there's a the statistical test is like 5%. Hey, we want to be 95% confident this aspirin's not going to hurt you. It's probably a little worse because I'm thinking about the FDA, but you know what I mean. 5% is a common test. A 1%, 99% confidence is a common test. We've got things that are 1 in 10 million. Instead of 1 in 100 for 1% confidence, we got 1 in 10 million. So incredibly good confidence numbers on the radiation numbers showing there is fusion occurring. Same when you look at the fuel and thrust and everything. So this thing went to town. I mean, those are incredible results. They're consistent with what we saw internally in our lab, and it's just been amazing to see it replicated.
So that's so cool. Again, like 7,000 follow-ups. So thank you very much for that. I guess the first question, I know you mentioned some of this on your website, which we will put in the chat for folks to go visit, just rocketstar.nyc. So you do mention that this is, getting close to space. Testing is in the near future. So I guess just that kind of schedule, what you're hoping to do in the immediate, and then just more broadly in terms of applications. So, ION, is this just for thrust capacity for satellites in orbit? Is it, potentially used for, like I know Dawn went out to the asteroid belt on an ION engine. So I guess just some of those more applications, both with this model and then further down the line. And I know that's like 4 different questions. So just start wherever you want.
Okay. Well, we have we have the foundation thruster, no fusion. We have a couple of in-space demos of that coming up.
Mm-hmm.
Right. So I remember I talked industrial psychology, and you used the great word import. People import their anxieties about here's what probably went wrong. It's like, well, here's what you didn't understand. But an in-space demo is absolutely required for people to have that last modicum of confidence. Because, I mean, these are bold claims, so we need to do bold demos. And, it's a lot of money people put on the line for anything that flies in space. There's a lot of risk. You've got to have a lot of trust. Oddly, I spent a lot of time in the chemical industry, and I will tell you, the space industry requires so much trust in a person's character, more than you would think. It's not just point click buy from a specification like you do out of a Grainger catalog. You have to have trust in the character because there's so much that's just so hard to document or can't legally be documented and shared. So trust is a very important thing. So we've got a couple of in-space demos to really back up the claims coming up. And then next year we have the fusion drive that's actually going to go to space. And that one's really kind of cool. I'm kind of geeked out about the design of that one because there's so many sensors. Normally people come to us and they say, look, we want as much fuel as possible. And this one, they said we need as many sensors as possible. And that's always, music to a nerd's ears. You want to get as much data as you can.
Yeah.
So data, not just longevity. So we're excited about that coming up. Applications. The asteroid belt you mentioned, that is a fascinating application because the power drops off so much as you drift away from Earth. There's the attitude here that solar panels are almost free. That, hey, if your thruster needs a kilowatt of power, so what? You just put on more solar panels. You're paying for that. And NDAs prohibit me from telling you all the landmines waiting for you when you try to buy that many solar panels. there's just a lot of hassle with that. Plus, you end up wobbling your spacecraft trying to deploy big solar panels. You end up cutting into if you want to keep one of the containerized, standardized formats, you end up cutting into your payload, your mission, making sacrifices there just to get larger solar panels. Or you end up having to pay through the nose for customized launch, customized container, stuff like that. So adding more power to the mission isn't always an answer, especially when it means you have to do things like you can't run your radio and your thruster at the same time because they draw so much power from the battery or from that. Modern communication dishes are miracles of manufacturing. They're incredibly precise. And they also heavily rely on getting a lock on the satellite. And if you fire up your thruster and you move outside of that lock zone, they are kind of hosed for a while. A few years ago, NASA abandoned a satellite in space because they couldn't get a lock on it in the first couple of days. It was cheaper to fly another satellite than to continue searching for it in a LEO orbit. It got found a couple of years after the new one went up. I mean, those are the decision economies working with. So it's very important to keep that radio running. And with these, Hall effect thrusters, which are gorgeous and well tuned, they're also power hungry. So they need many kilowatts to run. You can't run them with the radio on quite commonly. And if you want to take them farther away from Earth, the problems just get worse. Inverse square law worse, as you need bigger and bigger solar panels. And so anything power efficient is going to drive the future for space mining, Mars, etc. Anything further away from Earth that isn't Earth observation, power is the primary thing. Going to be a lot of water out there. I've talked with people who've done the chemistry for mining rocks, and they say water, oxygen, hydrogen are very common byproducts as they separate those things away from the useful minerals. So much so they're not sure what to do with it. And they're really delighted to see a water-based economy building here. The water here is also useful because it's safer to fly and it gets you cheaper flights. That's why you're seeing more of a push towards water propulsion here, is paperwork, industrial psychology again. But it's also going to be very useful out there. So applications are anytime you need to get somewhere faster, you need more thrust. You need to get there cheaper. You don't want to pay people on the ground while it's getting there. That's more thrust, delivering. Anytime you want to go farther away than Earth, or you want to dwell quietly somewhere, you need a minimum radar cross section. You want to sit at some Lagrange point and stare. You need a minimum cross section, so you want to keep your panels down, etc. Lots of applications.
So then I guess in terms of, and we had mentioned this before, what is the first physics constraint that comes into play when trying to scale this up, theoretically in the future? Could you make with this technology ion drives that are capable of, a much larger, crew vehicle that would be able to travel that far, or are there just limitations in, I don't know what the physics limitations would be in where it could go?
Those problems are a little hard to study because you always worry about the plumes commingling, what happens when they commingle side by side. And if you want to scale that up, I mean, this is one of our thrust heads. This is 5 thrusters. This is inside of the box I showed you.
Okay.
A bunch of these sit in there. This is one stick. And we've driven the complexity out of this and got these packed down pretty tight. Don't worry, that's all epoxied. I'm not showing you any secrets. That was expensive to come up with. We're not going to show that. But, these are packed pretty tight. But to get the packing efficiency that fits the form factor that gets launchable to space on chemical rockets, these have to be packed in to about 1/3 the spacing there already are right now. And so that's a real electronics challenge. It's a materials challenge to fit them together. It's a simulation challenge just to do the planning to play what if with it. So there's still a lot of scaling studies to be done there to really address that. I'd also saw somebody had flew by a comment, hey, what's your power in ISP? And I want to note that for the testing done at Georgia Tech facility, we are not releasing power and ISP done on their facility. We had to sacrifice a bit in order to be totally measurable by their system. So we don't quote those. You're not going to hear that. But for this guy, for the plain non-fusion version, this morning, this brother, this one I drove from a scrap bin, just in case I drop it or scratch it. This guy's brother had total thrust coming out of this in the 25 to 35 millinewton range, 1 to 2 watts input power pre-conversion, so less than that, making it to the output, and an ISP in the 4 to 6,000 second range. Bonkers. But, one of these ran for hours the other day, producing that steady state on a very well validated thrust stand mass flow system. Yeah.
That's just so cool. So I mean, unless I'm missing something, and I don't believe that I am, your demonstration next year will be the first demonstration of fusion energy in space.
To my knowledge, yes. I mean, there's several other fusion companies out there making fusion energy here on the ground, and there's several making good press releases about fusion propulsion opportunities. But as Dave likes to remind us, we're the first ones to actually get benefit from fusion propulsions. And I think we'll be the first ones to put one in space, demonstrating that benefit, measuring that benefit.
That's so cool. That's so cool. We are most definitely going to come back and talk to you guys again. Before you do that, did you want to jump in there, Dave?
I do. How'd you know?
There was something about your
yeah, that marketing look about you.
I'm like, is he leaning in? Is he ready?
Well, you can tell that we're so excited about what we do, but I know that we're kind of coming to the end, and maybe you can touch on some of the New York Space stuff with Mike. But what I wanted to do was just say, kind of take everything that we talked about now and put it into kind of what the new vision is. Yeah. And the new vision is beyond just access to space, because what we're seeing is the emergence of next generation launch vehicles. We believe that there will be a cislunar ecosystem that's developed. It will be developed before Mars because it makes so much sense to do it. There's a lot that we can learn by setting something up on the moon, and once we do that, there's going to be the supply chain. And we see all of these pieces fitting into that supply chain. Being in high demand for that supply chain. And then, of course, as NASA and those of us in the know start to look at those solar system objects that have water, and water translates into fuel, there's going to be opportunities that come down the pike, who knows how long or how many decades, where we're going to be moving outwards. And some of this, much of this technology, as it will evolve, will fit directly into that process. However far we go, that we can go during our lifetimes, we plan to be a part of that.
Well, I mean, all the different applications you've discussed with the software products for the deep space communications, for the radar sensing, and I mean, this making something more fuel efficient. Well, it generates more thrust. Sounds like an incredibly potent proposition if you are running an ion engine in space. So we are able to drift past 5 o'clock if we want. The meeting doesn't shut us down at an hour. I know Evan has to dip, but we can keep going for a little bit if we want, because I know that some people are going to have follow-ups. In terms of primary questions that I did want to return to real quick is that you guys are headquartered in New York. Your corporate offices are here in the state. Most space companies, a lot of the kind of pull of the industry usually leads companies to Florida, Texas, or California. And I know that you're not able to do all of the testing and manufacturing that you want to do here in New York. So I guess just kind of tell us about, your ties to New York, why it's important for you to be here, and then kind of your experience, building this kind of business in a state that might not necessarily be known for this kind of work.
So I'll jump in on that one. We originally, the three co-founders, Dave, Chris, and myself, we were all here. Dave was in New Jersey, but it's close enough.
Yeah.
And none of us wanted to move. None of us wanted to be in Florida or Texas or California. We were firmly convinced that we could do it here and that we could help bring manufacturing here. Chris is from Long Island, and he frequently talks about how when Northrop pulled out and it left all these neighborhoods that relied on those jobs, and now they're devastated. And one of his long-term goals is that he would love to be able to put manufacturing back on Long Island. We are presently headquartered in the Chrysler Building. It's hard to get a little more iconic than that in New York City.
That's pretty New York right there.
So we're very proud to be here. We're proud that we've been able to stay here for 10 years. We do have manufacturing, as you said, out of state. Right now it's in Florida. That's where Wes is joining us from now. That's a necessity in many ways. In order to build here, there's no launch facilities here.
Yeah.
So when we were focused on the rocket, it would have been cost prohibitive and almost impossible to build a rocket here and then have it flown or driven or by barge to Florida or anywhere that we could launch from. So that's one of the big sticking points here, is that even though it's not necessarily the most financially viable decision to stay in New York, we want to still be a New York company. We're very proud that we've managed to do that so far, despite other states trying to pull us away. It is frustrating at points. I know you spoke on this during your policy meeting earlier this week, that there's not a lot of support for the New York space community when it comes to the government, whether it be state, local, city. When we put out the fusion announcement, I fully expected someone in New York to want to tout that, to be like, hey, Florida and California aren't doing this. Texas isn't doing this. New York is the ones doing fusion. Here it is. We got it right here. It's a New York company. New York is killing it, and that didn't really happen.
And Mike?
Yeah.
So one thing I've noticed while working with the Rocketstar people that are from New York, Chris especially, is the hustle. The hustle. I've got to make this work. There's a lot of competition out there. We will adapt. We will change. We will make this work. I appreciate that hustle, because when I work with other rocket scientists from elsewhere, I tend to get told a lot more often, well, here's the right way to do it. And what I notice is the New York mind is, we just need a way of doing it. We need to move ahead. Let's keep going. And that attitude, I think, is incredibly valuable in moving ahead in the space world when the pace has to pick up. So wanted to let you know that's sort of an unexpected thing. Mike, I don't know if you're blind to it, because you're always immersed in that attitude of let's hustle, let's move this ahead. But it's not a common attitude in the space industry. There's too much, this is the right way to do it, or else, not let's pivot and move.
I will say that I see that in the other companies that I've met in this community. There's nobody, pardon my French on this, there's nobody in the New York space community that half-asses what they do. They are all in. They are super passionate. They are always excited. There's nobody at any of the company. I think your latest census, we're almost at 200 space companies statewide. Every one of them is just killing it. There's nobody that's just kind of here to be here and floating along. If they're not innovating, then they're dying. And
Yeah.
that's very much the New York State kind of mentality.
No, I appreciate that insight, Wes. I've heard a lot of different comments, but that's an interesting tidbit there. That's a rather unique feedback loop, and I very much appreciate that. And I guess to kind of continue on what you said, Mike, is that is sadly not anything new to us. You know, some of the barriers in New York, we understand. It's not the cheapest state to do business in. And the proximity to launch is just always going to be one of the capping factors for certain aspects of the New York space ecosystem. It just, you know, that one just kind of is what it is. I can't imagine that we will build a Cape Kennedy style facility in the Hamptons. That doesn't strike me as a proposition that would likely move forward. So and that kind of touched on some of the other obstacles, but I guess another pivot would be one of the things that we think is the strength of the New York space ecosystem is the academic talent, is the schools and stuff like that. So I guess just talk about maybe that dynamic a little bit in terms of the talent that you guys have needed. Has that changed over time? Are there skills that you're finding, you know, academia is not really generating the type of skills that kind of an innovative company that's looking at these kind of cutting edge applications? Are there gaps in what you need academia to be producing in order to thrive?
For that, I'll actually turn some of that over to Wes, because he's our hiring focus has shifted since we've moved more into the products that we're jointly putting out. As originally we were, focused on the rocket, and New York has no shortage of talent in that department. Harlem Launch Alliance, Columbia Space Association, just, there's constantly talent here for that. But as we move more into the software engineering and especially into the fusion areas, that's going to shift. And I see the majority of applications that we get coming in for those style positions are international. I don't know if that's necessarily a New York issue or an American academic issue altogether, but quite frequently we have international talent who are hounding us for jobs in those particular fields, including our newest hire, Diego. We actually hired him over from Italy. Wes, have you noticed anything in that regard?
Yeah. So at this stage in Rocketstar, we've got a lot of concepts that we're reducing to executable, repeatable products. Right. So that's technically moving from TRL 5 to TRL 7 or 8.
Mm-hmm.
So that's a product that is, shrink wrapped, ready to go over and over and over. And then at a certain point, we'll re-engage in innovation, and then you'll come back to implementation. So we're in that implementation hiring phase, and that needs people. That needs people that are hands-on, get the work done. Hands get dirty. Trust me, you've seen my keyboard. Hands get dirty.
Yeah.
Hands get dirty. You're in there. You're soldering. You're testing. You're coding. You're testing it every which way. Not spending a lot of time at the whiteboard conceptualizing what may be. You're spending time making something that will be soon on a deadline. And that type of implementation-centric person, I didn't find when we went out looking for recent hiring. That's where we got the international work with. Everybody I interviewed from New York, and I did interview some people from New York, such implementation was on their resume, but it was so long ago. They've been in management for so long. And I don't need another layer of management. I need somebody actually doing the work, turning the wrenches. I need more wrench turning and no additional supervision. Not for a while. Not when it comes to, okay, now let's roll these products out and let's then adapt them as needed, because nobody just turns a wrench. People have creative ideas. So it's not like the person typing in the code can't do design, but I need somebody who can do more than just design. So somebody with a business analyst in the title probably hasn't written enough code to be useful to me. And they certainly didn't pass the coding interviews I had to give, where I'm looking for the specific failure cases that kill production code. And what have you, how many times have you seen this? What do you do to prevent it? How do you design for it? How do you code against it? Defensive coding, et cetera, for the things that kill. Have you shut down, say, a server that's been running for a week? Why do you have to reboot that server once a month or something? There's memory leaks, things like that. So what have you done to deal with that? And so what we would have benefited from is if academia would encourage, even celebrate the notion that you're going to spend some time implementing code, that is deeply valuable. That the rush out of that into management, the person who tells me, hey, I haven't used data structures since college because I've been in management. I can make a project plan. Okay, well, then who's going to do it? How do you hire the person to do the work in the plan? I need that person who does data structures every day, who celebrates that, enjoys it. And I would speak also to HR to say, value those people. And we tend to say, well, if you're not managing, you're not as valuable. But it's I'm a big fan of the inverted pyramid, that your customer's first contact is with the person who last touched the product. And that's the person whose hands were actually making the product, who tested it, who validated it. And those people are incredibly valuable to the company. And if we can find a way to keep technical career paths as opposed to being promoted out of technical into management, then we would have more of this talent around. And so you got academics should teach more of a matrix style management so as to encourage technical career paths. And encourage companies to consider matrix stuff. We've got the people who enjoy management, co-working with the people who enjoy technical in order to do both functions that need to be addressed. So it's a management academics plus also teaching the students that it's worth keeping this deep technical knowledge, because then you can transition easier to another company and then move up in management. Those are my views on it, which we did not go through pre-coaching, guys, so I'm sorry if it's against your views. Feel free to debate. It's exciting.
No, you're good, bro. You're good.
No, that was actually really, really insightful. I like the concept of implementation centric and that kind of the need for hands-on. That was something we were kind of broadly aware of the industry might need, but to hear it described so succinctly was really helpful. Thank you. So I know I know we have some people here still in the audience. I know we've run past 5 o'clock. We're all having a great conversation, so we'll try to land it soonish. I don't know if anyone who's watching has a question. Feel free to pop it in the chat if you do. I know the Rocketstar guys have been great answering those. We can just touch on some of those in the chat if we want. We had one question that was sent in earlier from Alexandria Moreau. I do not believe he's on the call, so I'll put this out there. If you guys have anything to say on it, go ahead. How do you interpret the sale announcement of Firefly? What does that mean for the market for rocket launch?
I'll take a stab at that.
Okay.
It's probably going to be somewhat inadequate because we've been so involved with everything going on internally. It's hard to keep track of everything. But like any industry that is evolving, that has a lot of capital going into it, a lot of activity. I mean, we are all involved in a, hundreds of billion-dollar industry that is becoming commercialized. Like this is a special time in life, and we're all fitting ourselves into it in our own way. And so what's happening, like any industry that's ever gone through growth spurts, had a lot of money and being commercialized, you're going to have consolidation. You're going to have survival of the fittest. You're going to have companies with incredibly great, groundbreaking ideas that don't make it because they don't know how to manage people. They don't know how to manage resources. They don't know how to manage money. And it's just a great idea. So this, generically speaking, is just part of that process of the evolution. And I believe strongly that it just strengthens things. There's no downside to it. There's nothing bad about it. It's just making the whole ecosystem stronger and more resilient.
I would say it's also a white glove to the face, the old Victorian white glove, to say, hey, results still matter. In rocket science, a little more focus on results, a little less of here's the right perfect way to do things or else. And this is reinforcing that by essentially a paycheck to the face, pay stub to the face, smack, to say, hey, this actually matters.
Interesting. Well, thank you guys for your insights on that one. So do you want to advertise the specific dates? I know you mentioned that you have a couple of foundation thruster test launches this year. We have a question from Ivan about the aerospike. I think that was addressed earlier in the interview. If you guys just wanted to touch on it again.
It is linear. We've experimented with a number of different designs, and I believe the one that we're going with next is linear. We have put that launch off because of the sudden global demands for both DSP and the interest in fusion. We will have a launch, but that date is a TBA.
Okay. Hopefully that answered Ivan's questions. But I know you have some tests coming up. You said later this year for the foundation thruster, and then the fusion test is next year.
Yes. Dave, did you want to name those? I hesitate to name something marketing hasn't approved on those.
Well, no. I mean, go ahead. You actually are closer to it than me.
Yeah, there's a launch. There's a launch this June or July.
Yeah.
Foundation, July. That's a foundation. Results would take another month or two because you wait for your slot on a hosted payload, and you're moving the satellite, so your high risk things it gets deprioritized. That's how it goes. And another foundation thruster in October, November. Again, a month or two before we start getting results from that, and then a fusion thruster, I believe, in February, March
With the orbit.
No, fusion one's with Rogue.
Rogue. I meant
Deorbit is in the foundation thrusters.
Yeah.
Is the fusion thruster launch dependent on the foundation launches? If there are delays or something comes back that you need to rework with either of the launches this year, does that delay the launch next year?
You would love to have as an engineer, you'd love to have the ability to learn from one launch before you do the next. But we might have a week or two to learn from the first foundation launch before we have to deliver the fusion thruster for integration, just because these things take a long time. So very little learning time unless we stretch this over the course of an additional year, which is not really in our financing plans.
That makes sense.
So we're learning aggressively every time we can, every way we can. Keep our lab here pretty much saturated with thrusters firing and looking at large data sets or growing late data sets for that, learning everything we can. But project schedules are bonkers in terms of the lead time. It's, again, not a consumer type experience. You hand it over and it could take 6 months to a year from the time you hand it over to the time it launches, but you can't change anything about it during that time.
That is definitely an issue. So yeah, we are now at 5:15. I had a feeling that this one might run over. It's the last one of the week. I guess I just don't want Space Week to end. I know some questions have come up in chat. I want to thank you guys for answering them. So we are going to start to bring this down to a close. I don't have any other major questions on my list. I mean, I could talk about for the next like 2 hours if I wanted to, but for event purposes, we are going to start to wind it down. So if we don't see anything else in the chat, I guess I'll just turn it back over to you guys for a final. Are there other projects that you wanted to highlight, upcoming events, website, blog, anything that you want to push? How can people find you? Just kind of, take us home.
I think what we want to do, well, you put the rocketstar.nyc.
Yep.
We're accessible through social media at Rocketstar Space.
Yep.
And I think on behalf of Rocketstar, the three of us here, the two guys in Japan, we want to thank you, Patrick, for including us. We also want to congratulate you for what we've heard has just been a good series of events. So well done.
It's been a great week. Spread of events. We've had people all over the place. The in-person event went fantastic. And this is the kind of event that we like to have, highlighting the cool companies, because it goes back to what Mike mentioned a little bit. One of the biggest challenges here in New York is just so many New Yorkers are unaware of the awesome work that's happening in space in New York. So, the fact that we have a company that's headquartered here that's working on, what will be the first use of fusion energy in space is insanely cool. So we are very happy to help promote that. We will be happy to continue promoting that. We'll have to have you guys back again for Space Week next year to tell us how it's going. We will send out an email to all the attendees and to everyone who RSVP'd with all the links, and then the full video from this interview will be posted on YouTube afterwards. So yeah, just a thank you to everyone who attended and for interacting in the chat. Lots of great questions came in. We were hoping that this was going to be a responsive crowd, and I'm glad that people were here and were interested. Thank you, gentlemen, for taking the time. I know we ran late. That wasn't planned. So thank you for taking an extra 20 minutes to let this run long. I'm sure all of the viewers and the guests are very happy with the extra time to talk about stuff. So yeah, thank you all very much. Have a great rest of your evening.
Be well. Carpe Astra.
Carpe
Appreciate
Astra.
you, Patrick. Thank you, man.